manner that it goes is you're able to pair itself off of the reference angles. And getting reference angles and building these things out is kind of the key to the entire setup. And all you have to worry about is your 30-60s and your 45-degree triangles, and everything builds off of that. I asked you guys to finish building out, so let's just kind of briefly make sure you got them correct starting at the 45. 45 was pi over 4. Then you start thinking about, all right, what's the cosine value of 45? What's the sine value of 45? They're the same, right? They're both what? Good. So they're both root 2 over 2. Now, as you mirror yourself into the different quadrants, it's just a matter of adjusting positive and negative. So if you go to the second quadrant, the x values become negative, and the x values are what?
Negative.
Cosine. Look at that.
Oh.
So you have negative root 2 over 2, and then root 2 over 2. And remember, this is the reference angle. You're coming up pi over 4, so you're at 3 pi over 4.
Oh, I forgot to
To the radians. Make sure you rationalize, okay? When you go down into the third quadrant, you're adding a pi over 4. Yeah.
You just needed to have the, in the parentheses, actual thing, right?
Yeah.
Okay.
That's all I did.
Because I didn't have this 3 pi over 4.
Oh, make sure you have those. You got to know where those are for your references, okay? Build this down a quarter, and you're at 5 pi over 4. And they're both negative. Okay. Yes, ma'am. When you're looking for the cosine, if you're at the cosine of 45, the cosine of 45 is 1 over root 2. Rationalize. That's all. Okay. And that's the same thing as this.
Wait, and that one where it's 5 pi over 4, they're both negative.
They're both negative because it's negative. Everything's negative in the third quadrant. Fourth quadrant, you're a pi over 4 away from 2 pi, so that's 7 pi over 4. And root 2 over 2, and negative root 2 over 2. So far, so good on that?
Wait. Oh.
When you go to your 60-degree angle, your 60-degree angle is always going to be your pi over 3s. It's a third of the way around. If I'm at pi over 3, 60 degrees, my cosine of 60, 1/2. And then it's root 3 over 2. Mirror it. You are now at 2 pi over 3. Move it down, going past the third. So you'll be at 4 pi over 3. Both negative. And then be a third off of 2 pi. So that would be at, what would be 6 pi over 3. 6 pi over 3, so it'd be 5 pi.
Yeah.
5 pi over 3. 1/2, and then negative root 3. Remember, it's not the whole thing that you have to have this memorized. You don't need to memorize this. All you have to know is how to get a reference angle. Then you're fine. What do you mean?
Oh, it's cosine and sine.
Like
X and Y is cosine and sine.
Yeah, I know.
But you're trying to figure out why they're going the way they're doing? I'm taking the cosine at 30 degrees, the cosine at 45, cosine at 60. Cosine at pi over 2.
He's making triangles out of those angles.
My theta value,
Oh, and then do your radius is 2?
radius is always 1 in the circle, because here you're at 1, 0. No matter what happens here is they're all built off of this. Everything's built off of off this. These 3060s and 4545s, those were the special patterns where we say it was x root 3, and 2x. What was going on there is that value of x was some pattern. That's where that comes out of. All right. Now, one of the things that we spent a little bit of time on Friday, I think, was we worked on some of the quadrantals. What I want to do here real fast is revisit how you get trig functions on a quadrantal, and then how you're going to be able to use these. You know what? Let's go. We'll do it in different order. Let's do the trig values off reference angles right off the bat. Then we'll go back to quadrantals. Before I do that, I want to show you guys a little trick. We agree on that, right?
Yeah.
Okay. Probably. We agree that that's correct, right? We also agree that our ordered pairs go cosine, sine. We agree on that? Here's what's going on. Cosine, sine, and tangent are all going to be positive in the first quadrant, which means all of their inverses are also positive. They're all positive in that first quadrant. All right. When you go to the second quadrant, the x values in the second quadrant are always what?
Negative.
So what happens with cosine then? It's always negative in the second quadrant. Secant is the inverse of cosine, so it's also going to be negative. Sine values are always what in the second quadrant? They're positive, because it's the y value. Now here's where it comes into play with the tangent sine. When you're dealing with tangent, it's your opposite over adjacent. You agree? Now, when you have opposite over adjacent, if I'm in the second quadrant, this is positive and this is negative, isn't it? So what's tangent going to be? Careful.
Negative over positive, so it'll be negative.
Negative. Because see how they're alternating signs? Tangent's always negative in the second quadrant. So is cotangent. Because look at the triangle. You have a positive y value and a negative x. Tangent's y over x. Tangent's sine over cosine. Okay? In the third quadrant, really annoying the board. In the third quadrant, just rough idea here, everything's negative, right? Your x values and y values are negative.
Yeah.
So won't cosine and sine both be negative in the third quadrant? Yeah. Now think about tangent. Tangent is opposite over adjacent. Negative over negative is
Positive.
positive. Okay?
So sine and cosine are just going off of the ordered pairs
Yeah.
there, cosine. And if x is positive, cosine can be positive. Okay.
That's all it is. When you go into the fourth quadrant, cosine is what in the fourth quadrant? Positive. Sine is Therefore, tangent is negative. Yes, sir?
So if sine of our curves is negative, then we'll show you have tangent will be negative. So
No. Look at the third quadrant. See how they're both negative?
Yeah.
You have to have, and this is, think of it this way, it's a negative divided by a positive. It's a positive divided by a negative. It will always be negative in the second and fourth quadrant. Negative divided by negative is always, and the positive divided by positive is always your positive diagonal, okay? So don't automatically assume since you have a sign value that's negative, it's automatically going to be negative, because it also can have negative cosine, okay? And it's just the idea of being able to play across what quadrant you want to end up in. Once you find out your quadrant, your reference angle, all this just falls into place, okay? Now, here's what we're going to do. We're going to go a little out of sequence here. I'm going to find the secant of 120 degrees. And I'm not using my calculator. I'm using reference angles. Okay?
Are we still in?
This is still 13.3. This is still 13.3. I want to do and work with secant of 120, and you're going to see how easy this stuff mirrors itself out of within the next 15 minutes. I pretty much can guarantee a lot of you are going to go, oh, I get it. This happens a lot in this section, right? So, secant 120. What quadrant is 120 degrees?
Second.
Second quadrant. We come across, second quadrant is 120. What is its reference angle? 60-degree reference angle. So I have a 60-degree reference angle, which means I'm going to use a 30, 60, 90 triangle. Are we okay with that?
Yep.
Secant is the inverse of what trig function?
Cosine.
Cosine. So cosine is adjacent over hypotenuse. So what's secant?
Hypotenuse
It's 2.
And what does it equal?
2.
2. But now, what quadrant are you in?
Oh.
Is cosine and secant, are they positive or negative in the second quadrant?
They are negative.
It's negative because it's the second quadrant. Go to the next problem.
So it says it's 2, but because we know we're in the second quadrant, we have to make it. Okay.
So do your like side thingies never change? Like you never have like
No,
root 3x? Like
No.
x doesn't, it's
No.
just that?
it's just this.
Okay, cool.
I told you, you guys are going to go and you'd be like, holy cow.
Okay, like we've been going through this and I've just been expecting you to like drop this like huge bomb of something really, really hard. I didn't think it would lead up to this.
That's all it is. Because eventually you're going to be able to do this. Solve that equation. Because you're going to,
Correct.
yeah. Because you're going to be asking yourselves what angles have the cosine value of something. And work backwards. And you're going to have to believe me that this all comes, I won't say full circle, but you get the idea. It is extremely based off of this reference angle. Everything bounces to a reference angle to one of these triangles. Are you going to have angles that have reference angles that don't go in this triangle? Yeah, but you have to have a calculator to do that.
Why is it negative? Why is it negative?
It's negative because it's the second quadrant, and it's the inverse of cosine. Cosine values are negative in the second quadrant. That's why. All right. Let's look at another one. Let's say we have the tangent of negative 315. I'm going to do the tangent of negative 315 degrees. First thing I'm going to do is get my reference angle. Careful. First quadrant.
So you go
Very good.
this. Oh, I get it.
The negative, so I'm going the other direction. I spin it around. 315 degrees gives me a reference angle of what? 45. It's a 45-degree reference angle. I have a 45-degree reference angle. I'm working with a 45, 45, 90 triangle. Tangent is what over what? What's tangent of 45? Which is 1. It's first quadrant, so it's tangent positive or negative?
It's crazy.
Change your mode. She doesn't believe me. I am.
Whoa. This is crazy.
Okay. Told you it's. I'm not trying to mess with you guys more than normal.
I like how you have it divided up by time of year. Spring 2015.
I wouldn't call it.
Oh, my folders.
Yeah.
You have to have folders in the right spot, otherwise everything just goes all haywire. Cotangent. Hey, it's convenient. I have a cotangent example next. You're not degrees. All right, so I'm going to find the cotangent of 7 pi over 6, which means I have to figure out what quadrant I'm in to start with. Don't go 2 degrees. Don't even need to look at your unit circle.
Just kidding.
Here's what I want you to do. You know that that's pi, right?
Yeah.
And you know that this is 1/6 more than that, right? What's my reference angle?
Well, your angle is
Pi over 6. I'm pi over 6 past pi. I'm 1/6 more than 6 over 6. Pi over 6 is my reference angle, so pi over 6 corresponds to which angle? 30, 45, or 60? Try again. 30.
Oh, because your reference angle bounces off the horizontal.
Yep. The reference angle bounces off. So you're in the third quadrant. You know it's cotangent, so it's going to be positive or negative?
Negative.
Positive, because they're both negative.
Wait, I thought it was
So we're at a 30, 60, so we're at 1, root 3, and 2. About what?
because, okay, so for the like 7 pi over 6 it's positive, so you want to counterclockwise, right?
Yep.
And that's
What I want you to think of,
pi.
pi is the same thing as saying 6 over 6 pi. Do you agree?
Right.
So it's 1/6 past it. So the reference angle here is pi over 6. Pi over 6 corresponds to the 30-degree angle.
Okay.
Okay? So at 30, I'm looking for my cotangent. Tangent, opposite over adjacent. Cotangent is adjacent over opposite. So it is positive root 3. That's all that is.
It just like doesn't
What's
end
that?
up how you think it would.
Because pi over 6, the reference angle for pi over 6 is 30 degrees. Here's a little trick that you guys would figure out, hopefully in the near future. When it's over 6, it's a
like
30-degree
60,
angle.
30, and it's over.
And when it's over 3, it's the 60-degree angle.
What is it for 45 still?
It's always over 4.
That's pretty
4
good.
as in 45.
Okay? Cosecant 2 pi over 3. Cosecant 2 pi over 3.
Yeah, I remember that.
So
That's second quadrant. Oops. I
But
really...
it's going to be a 60 degree.
Correct.
Right?
Because our reference angle is pi over 3. So it's working with a 60-degree angle.
So you're on a 30, 60, 90 like that.
So it's root 3, 1, and 2. So cosecant is the inverse of sine. Sine would be root 3 over 2. 2 over root 3.
which is 2 root 3 over 3.
Very good. Now, cosecant is the inverse of sine, and is sine positive or negative in the second quadrant?
Positive.
It's positive because it's the y value, so therefore your answer is just 2 root 3 over 3.
How do you know that stuff? I don't know how to tell them.
What do you mean? Positives and negatives?
Yeah.
Do you know when you're just looking at an xy, when you're looking at just plain old boring X and Y.
Right, that one's gonna be like two positives. It's gonna be like over there, it's gonna be negative, positive, negative, positive.
And then in this case, remember, cosine is X, sine is Y.
So whatever quadrant.
Every single time.
But then when it's like cotangent, or like cosine.
Then it's just the inverse. The sine, SIGN, stays the same.
What makes cosine X?
Math.
When you place itself through, remember we wrote a little bit of these things when we did our, last week we did square root x squared plus y equal that r value when you replace with an ordered pair terminal side of theta. We did a little bit of that. Yeah. You were getting that r value. Okay. It just so happened that the values that you guys were doing with ordered pairs were a little bit different. You had to solve for stuff. Okay. Now, if you're at a 30-degree angle and you're placed theta at a 30-degree angle here, if this is 30 in a regular 30, 60, 90 triangle, your opposite the 30 is 1, opposite the 60 is root 3, and opposite the 90 is 2. So no matter what I do with this, this mirrors itself in this quadrant. It's still opposite is 1. The adjacent is negative root 3 because my theta is here and I went to the left. If I mirror it down here, it's negative 1, still at negative 3. If I mirror it here, it's still positive root 3 going this way, but it's negative 1 because it moved down y. Your idea of theta bouncing off the x-axis is giving you this reference angle for all of these. That's why this works, because you've got a reference angle here, 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 here that are all the same. Yes, ma'am?
Does the hypotenuse change?
No.
So it's always going to be positive?
Yeah. Because x squared plus y squared is always going to give you a positive value. Right? That's why that doesn't change. Christian, you're not buying. What do you got? Narrow that down.
Like, what's X?
Yeah, that's what I'm looking for. I don't
X.
understand this whole
I
thing.
understand it's cosine.
Your x value is you moved over root 3. So x would be root 3 over your hypotenuse of 2. That's why it's root 3 over 2. Your x value is root 3. When they say this, as you get into the whole grand scheme of your ordered pair, you're getting the cosine value of root 3 over 2, x over r. The sine of 30 was 1 over 2, y over r. It builds itself out over your ordered pairs from this. These are just coordinates. These are just spots. That's all they are. They're places in space. Right.
Cosine doesn't equal X, cosine equals X.
Correct. We call it x because what was our ordered pair at 30? It was root 3 over 2. The ordered pair itself was root 3 over 2 and 1/2. The x portion of that ordered pair was root 3 over 2. That's why that happens. Yes, ma'am.
Okay. So you're saying that the hypotenuse is the radius, but then you're going on about how, like, on the horizontal line, it was 1.
Right.
So how can the radius be 1 and 2 at the same time?
I'm going to show you that one next.
Okay.
When you get into the quadrantals, when you get into plotting out on your quadrantals, you don't have to write all this out. It's kind of easy just to kind of bear with me here. If theta is equal to 0, theta is 0, your ordered pair is on the x-axis. When you're on the x-axis, your x value equals r.
Yes.
So it doesn't matter what r is, because it's always going to be constant between that and x. So if I wanted to look at it being a cosine value, cosine is x over r. If r is the same value as x, what's it always going to be? 1. So if it is 2 over 2, what's 2 over 2? 1. If it's 7 over 7, what is it? 1. It always equals 1. That's why the ordered pair here is at 1 and 0. When you move up, your sine, or excuse me, your cosine value will still be x over r. Your x value on the vertical axis is 0. What's 0 divided by r? No matter what r is, what's it going to be? 0. Your sine value is y divided by r. If they're the same numbers, what's it always going to be? That's why this works. That's why it becomes 0 and 1. It moved the direction change. It's the opposite. Excuse me. That's why it's negative. And that's why it's negative down here as well. That's why that works, because your x's and r's, when you're horizontal, your x and your r value are the same. No matter what number they are, it's always going to equal, when you divide it out, it's always going to be 1.
Okay.
That's all it is.
So you're saying that really, like, in that last example with the 2, basically, like, the radius really is 2, but it divides out.
Yeah, because as you divide them through, it becomes 1 as it goes through, because it's not that the radius itself is going to wind up being, if it is 2, when you get up here, what's 2 divided by 2? Radius can be 7. It's still 1 with itself vertical. That's all. It's just a ratio. It's a ratio of size. And it works, it's just magical. That is, it will.
Magical.
Yeah, I've never said that in here?
There's nothing magical about this.
Really?
It's just a magic.
So, I did. So let me show you this then. As you go through these,
Wait, can you write that down? I
What?
want to know how to spell it.
It's
IT.
magic. Magic.
I would like to know how to spell magic. Make it up.
Okay, let's try these.
Add it to the
It's math.
Yes.
Magic.
Well, there has to be something.
Let's do this again. Let's go to cosine at 210. All right, we'll go to cosine 210. First thing we're going to do is try to find a reference angle. When I go cosine 210, I'm in the third quadrant. How far off of the x-axis am I? 30. So what's my reference? 30. Cosine of 30 degrees is what? Okay, so it's root 3 over 2. And then is it positive or negative in the third quadrant?
Negative.
Go to the next problem.
Hello. Wait, okay, wait. So then it's negative.
Yeah. Well, it doesn't matter. Yeah.
Oh, because it's like a 30, 50, 90, and then like that side is okay.
Right. It's the root 3 because the root 3 is the x value. The x value has moved to the left. Okay. Now, when you go into the tangent of 7 pi over 3, I'm going to go into that one. I go 7 pi over 3. When you're dealing in radians, you've got mixed numbers. A lot of times, this is really the only instance that using a mixed number sometimes is more helpful. 3 goes into 7 how many times? Twice, and how many are left over? 1/3. So what do you think your reference angle is going to be? 2 and a pi over 3. So you come around, and you're in the third quadrant, or excuse me, you're in the first quadrant with what reference angle again? 60. So if I'm 60 degrees, first quadrant, tangent, I know it's got to be positive. Your 60-degree tangent is root 3 over 1, so it is.
Wait, if it's over 3, it's 60.
Yep.
What is it for 30?
Over 6.
Over 6.
Yeah. It's kind of a little trick that
And then the 45 is 4.
yeah. You'll start to pick up on that,
What is number 2?
and then it's a 90. It's either a pi over 2 or 3 pi over 2. It's one of those.
Yeah, you're right.
It's crazy. Sometimes I know what I'm doing.
Well,
Just a mess.
you fixed the smart board this morning, and it was a PowerPoint.
I know, and I didn't swear at it. Weren't you proud of me?
Wait, you fixed the smart board?
I did that, and I even started a PowerPoint. And you know how much I love PowerPoint.
Where'd you do this? Why?
Take a second, do those two.
Yeah, I'm always there.
If I'm at secant of negative 315, one of the things that you guys will have a tendency to do when you're working through this is you're just going to go the wrong direction. It's negative, so you go clockwise. What's your reference angle going to be? It's going to be 45. Secant is a cosine. Is cosine positive or negative in the first quadrant? Positive. The cosine of 45 degrees was 1 over root 2. The secant then would be root 2 over 1. So your answer here is?
Root 2.
Root 2.
Sweet.
Yes, ma'am?
Sorry, this is about this like testing schedule.
Yeah.
So we like come to school at like regular time. and
Yeah.
then-
They'll make an announcement and tell you guys to leave.
Oh, okay.
Okay. Yes, ma'am?
I didn't know.
What if we just like...
Because in the first one.
What if I like negative power outage and then just like... What if someone just like we're on the treadmill we get lunch home?
You have to eat it.
Yeah.
We already have it.
Sine negative 3 pi over 4.
I like it.
Sine negative 3 pi over 4, you're going the opposite direction again, and you're winding up in the third quadrant. What's the reference angle going to be? 45 again.
Oh, yeah, because it's happening.
It's because it ends in the denominator is a 4, so it's going to be a pi over 4. Now, so 45, guys, don't worry about it. You've got a week and a half to worry about it. Sine of 45 degrees is how much? Root 2 over 2. Root 2 over 2 is sine. Stop clicking. I'm going to give you a different pen. Will the sine value be positive or negative in the third quadrant?
Negative.
So your answer is negative root.
Whoa, wait, whoa, I lied.
2 over 2.
I thought you,
Okay.
sorry.
If it said tangent, then it would have been 1.
You're right.
Oh, third.
I wasn't thinking.
Okay. It's not as fuzzy, I hope. Is it? Has the idea of where this is coming from starting to enlighten a bit, I'm assuming? Now, will you be able to do stuff like this, then?
I mean, yeah, if we use calculator stuff.
You can move!
There's a seat right there.
When this happens, guys, you press a button, okay? Everything that I'm going to be giving you is all non-calculated. Yes, sir?
Wait, so when they give it to us like rates like this, we each have it in degrees, right?
Yeah.
And then when they give it to us with pi, we have it in radians.
Like other tests, just give us a couple problems like that, just for like reasons.
No.
Yeah.
So we don't have to have
then
that
people would like additional smart credit opportunity
Let's try 2 more, then I'll give you some stuff. Sine of negative 60. Oh, no. What do you think your reference angle is? 60. If it's negative 60, what quadrant does it drop into? You should be able to pick this up right away. Sine, is sine positive or negative in the fourth quadrant?
Negative.
It's negative. So 60 degrees sine value. 60 degrees sine value, root 3 over 2. Okay, root 3 over 2. Cosecant, 2 pi over 3.
60.
Cosecant, 2 pi over 3. Gives me over to second quadrant. Has a reference angle of?
60.
60. Sorry. I'm sorry. So cosecant is the inverse of sine. So sine of 60 was root 3 over 2.
2 over root 3. So 2 root 3 over 3.
And is sine positive or negative in the second quadrant?
Negative.
Positive. The y value.
Okay, right. Sine is
Like sine is y, cosine is x.
Did you guys like copy down the little chart?
Yeah.
What little chart?
Remember I just listened through and I wrote down all the sine, cosine, tangents? Thanks, Frank. Oh, yeah, that one.
Copy down.
I'm trying to do another chart.
Just remember, just remember your positives and negatives. If you remember that, it just flows
I'm
through.
just trying to picture the board triangle.
Yeah. Does that help when I showed you how that it's bouncing itself through with just those values? That's all it's doing. Okay. What's going to happen here is we're going to eventually do this.
What is wrong with me?
I can tell you a lot, but
Whoa, whose homework is this? Well, why'd you rip it up? Why does it need to be ripped up to be recycled?
what you're going to be able to do over the course of the next week or so is this. You're going to be able to take an equation like this and solve for x. Now, if you have to move stuff around, what I want you to see here is root 3 times a cosecant of x minus 2 equals 0. If I'm going to solve for x, I've got to move all my stuff first before I get to the cosecant.
Cosecant of x equals root 2 over 3.
So, and you have a cosecant.
Cosecant is sine, so sine is
CSS.
So then, what you're thinking here is, which angle has a sine of root 3 over 2? Which angle has a sine of root 3 over 2? 60. Okay? It's 60 degrees. So, because this is a reference angle. Okay? Now, if you think of it as being a 60-degree angle, where else is sine positive? First and second quadrant. So if one of them is 60 degrees, what's the angle in the second quadrant? 120. Yes, ma'am.
I'm confused, so you don't have to rationalize.
I just left it like that because I was saying, because if I flip it, because I'm working with the reference angle.
Oh, okay.
And notice how we did all of that thought process and never once touched the calculator. That's what we're going to be able to do. Yes, ma'am.
How do you know the angle is 120 and not 60?
Exactly.
Because the sine value is both positive root 3 over 2 in both the first and second quadrant. 60 degrees, the reference angle in the first quadrant, coming up 60 degrees puts me at 120. Remember, we have the two.
Wait,
We have the 2 points here.
It could be either one.
Yeah, there's two different angles.
Okay.
And we'll get into this
Like
more.
120 and not 60. So.
Yes, ma'am.
Wait, so x is 120.
Or 60. And this will be the only time that I talk about that in degrees, because from here on out, it's all going to be done in radians. But it's not bad. Yes, ma'am.
Okay, sorry, going back to this part schedule that you gave us. Is M102C, is that the media center?
Maybe.
Maybe
North
that's
Wing is
M?
Maybe that's just this
That-
one.
Because my study hall was N103.
Maybe M is for mathematics.
As in M?
Yeah.
Maybe it is media center. I don't know.
I like the room we took it in
It
last
says we
year.
don't need to bring anything. Should we bring a calculator?
Yes, bring your calculator.